Simply stated, the JavaScript engine is a program that executes JavaScript code. So looking at our diagram, if we have some JavaScript code, the JavaScript engine is in charge. It is the only piece that knows what to do with the code. It translates it into something that the computer can understand. Now, initial JavaScript engines early on were interpreters, which means they would process the JavaScript code line by line, convert it to bytecode so it could run. Interpreters are quick to start running the code, which is something that was needed in the browser environment. But they can be slower overall when compared to compiled code. Compiled code is converting the program to machine code so that it runs optimized. The latest JavaScript engines are much more optimized. They use a combination of an interpreter and just-in-time compilation or JIT compiler to optimize the code. This gets the best of both worlds. JIT compilation takes code that can be optimized and compiles it. For example, if a piece of code runs a lot, it can be compiled to machine code, and then when that piece of code is run, it is optimized and therefore faster. Now, there are a number of JavaScript engines. The one that is probably the most well-known is the V8 engine. This is the engine that is used in the Chrome browser and also in Node. This engine was written by Google for Chrome using C++, and it is open source. It is probably the most well-known engine because when it was built, it improved the speed of existing JavaScript engines. Google was using JavaScript to do some pretty amazing things at that time. Think about the different Google apps written with JavaScript. Anyway, they wanted it to be more performant, so they wrote the V8 engine to accomplish exactly that. Other JavaScript engines followed suit in order to make their engines more performant as well. This improvement in performance is important to be aware of. This idea of using a JIT compiler with an interpreter to help optimize the code. And the reason this is important because we talk about writing code certain ways to make it more performant or avoid things in our code that could make it less performant. Many times it has to do with the way the JavaScript engine handles the code and is able to optimize it. Now, here are some other JavaScript engines you may have encountered. We've already mentioned V8, that it was open source, it was developed by Google. It's used in Chrome and Node.js. SpiderMonkey, this was the first JavaScript engine, and today it's used in Firefox. And incidentally, the first JavaScript engine was written by Brennan Eich when he invented JavaScript, and as the story goes, did it in 10 days. Now, JavaScript Core, that's also open source, and that was developed by Apple for Safari. So that's the engine that Safari uses. Another one we should probably mention is Chakra, and this is used in Microsoft Edge. So Microsoft's JavaScript engine. Now, with all these different JavaScript engines in different browsers, how do we know that the JavaScript code we write will work the same way in each browser? Early in JavaScript's history, this was a real problem. There were differences. In those days, we spent a lot of time worrying about differences in browsers. Libraries like jQuery helped solve that issue and became very popular because of that. Now, because of these differences, there needed to be a standard, and that is where ECMAScript comes in. This is a standard that JavaScript follows. An ECMAScript is a specification that all JavaScript engines now follow. This allows multiple independent implementations, but it ensures that our code works the same. So when changes are made in the ECMAScript standard, the engines must be updated to support these changes. Some updates are faster than others. And that is why we have sites like this one, caniuse.com that tell us which browsers support certain implementations. So we can see the history of different browsers and when they started supporting ES modules in this example. Now, that is also why we make use of transpilers. A transpiler like Babel lets you write code using the latest ECMAScript standard, but then outputs JavaScript code to an older standard. So an earlier form of JavaScript that older browser engines can run. This can also be called a compiler because technically you are compiling code to another form, an older version of JavaScript. All right, so that is enough about JavaScript engines. Now we need to get more into the details and talk about the heap and the call stack within the engines. These two things are used frequently when coding in JavaScript, even though you may not have known about it.